Welcome back, guys. This is the program that ties everything together. In this program, we use Async.io, Serial, AIOHTTP, and Socket.io to combine to create an application that will be able to take information that we get from our serial port and then send it to a Flask server that will then operate a client in our browser with our IoT dashboard so that we can send sensor data from our Arduino analog input directly to the web page for updating and displaying for sensor visualization. So first we import the required modules. We import our Async.io, Serial, our AIOHTTP, and Socket.io. The Async.io handles all our asynchronous operations, and the serial is for working with our serial communications with the Arduino. We have our AIOHTTP for HTTP requests, and then Socket.io provides the Socket.io functionality. Now the first thing we do is we set up our Socket.io client and serial communication. So we initialize a Socket.io client, SIO, and we set up a serial communication, SCR, on port COM3 at a rate of 9600 baud. Then we have our event handlers for Socket.io messages. So we have our decorators, and we have event handlers for turning on the LED and turning off the LED with messages received from the server via Socket.io. And these functions send commands 1 or 0 to the Arduino. So when we send one command, we'll turn on the LED. When we send a command of 0, we'll turn off the LED. And this is of course dependent on the messages that receive from our Flask server, which then communicates with the client, and these event handlers will handle that operation. Then we connect to our Socket.io server. Our Socket.io server is on port 5000, and this connects Socket.io client SIO to the server running at localhost 5000. Then we have our asynchronous functions for sensor reading and data transmission. So what these functions do is, this function reads a sensor data and puts it into a mailbox, and that mailbox, while sent to server, retrieves data from the mailbox. It sends it to the server via our HTTP post request. So we'll first take a look at our read sensor function, and this read sensor function, right, first we have an empty string named sensor value to store the sensor data, and then we start an infinite loop to continuously read the sensor data. Now we first check to see if there's any data available in the serial buffer, and if data is present, the code will proceed to read it. Now the way we read it is we read all data available on the serial port using this serial.read command, and then we decode it with the code assuming it's in string format. Remember we covered that earlier. Now we have sensor value, and this accumulates characters, and this is to ensure that combined with this sensor value that split at the new line character ensures that it accumulates the values into one whole value rather than as a stream of characters. And then if we have at least one complete value present, by ensuring we have more than one line, this will indicate that we have complete sensor data. So what we then do is, if the complete values are present, we extract all but the last line being complete, and it is stored for the next iteration. Now all this buffering and stuff, what I found is that this buffering doesn't allow for real-time updating. So the serial buffer and then the buffer to the web server will allow for this accumulator to take a long time to allow for change. So in order to prevent that, I set up a mailbox, and what this mailbox will do is that this mailbox will allow for storing data, and it allows the coroutine to put data into it and another coroutine to retrieve data from it asynchronously. And this mailbox just has a size of 1, and the reason for that is that by setting the mailbox to 1, we only allow for one sensor value. So this code construct here it's adding the cleaned and formatted sensor value into the mailbox using await, and well, we know the await keyword is used to put in an asynchronous operation, it adds adding the sensor data to the mailbox. Then we have the actual function that handles the sending to the server. So the function is asynchronous and it takes mailbox as an argument. And if we notice, the mailbox is present as an argument in both of our async functions because they are both sharing this mailbox. Then we have our URL definition, and this defines the URL endpoint where the sensor data will be sent to via the host request. Then of course we create a client session, and we use AIOHTTP to establish our client session that will manage connections that allows for making the asynchronous HTTP request. We then retrieve the sensor data value from the mailbox, and what we do is we asynchronously retrieve the sensor data, and it will block until there's more data available in the mailbox, right? So that will prevent any type of threading issues. Then we construct JSON data, and we construct this JSON data from the value retrieved from the mailbox. We format it into a dictionary named data, right? And the key is our sensor data that will hold the sensor value. So essentially what we're doing is we are taking our data from our sensor, encoding it into JSON format, and then once we have that, we can send it to our server. So the way we send to our server is asynchronously with an HTTP post request to the URL with our formatted JSON data. And we have here our responses. If it is that the server indicates success, we'll get this message here, and if it is that the data wasn't sent properly, we'll get a fail reading here. We then have our infinite loop. When it's structured like this, within this this infinite loop, we continuously check any mailbox and we send to the server. So the way we orchestrate our tasks is with main, and main now is another asynchronous function that orchestrates our execution of our read sensor task and our sensitive task concurrently within an async IO event loop. So we first set up our mailbox, and this is our mailbox. We are using a queue here to do it, an async IO queue, and we set the max size to 1. Like I said, so only hold one sensor value at a time, so there's no buffering. As soon as a sensor value comes in from the serial port, it's directly sent to the server and to the web page. So there's no delay, no buffering, right? Because the buffering eliminates this real-time data aspect. Then this here is where we actually create our two asynchronous tasks. So we read the sensor data, put it into the mailbox, and then we retrieve the sensor data from the mailbox and send it to the server. And of course we use this gather method of the async IO class to concurrently execute all the defined tasks, right? Which is read sensor and our send to server task. So what this line is doing is ensuring that both tasks are run concurrently within the event loop, asynchronously, processing data and send to the server. And then finally, we have our async.io.run main, and this executes our main coroutine within the async array event loop using async.run. Right? So this starts the concurrent execution of the read sensor and send to server coroutines that we developed. So this is the first part of our application complete. And of course, this COM port value, you can change it to whichever COM port the Arduino is on. And in the next video, we'll look at how we can actually set up Flask server now to handle our interaction with this program that we have written.